Welcome to video 2 of section 410, antiderivatives. So this is where we left off in example 2, and I wanted to just highlight the fact that I used some very simple notation taking the antiderivative of this expression. And if you noticed, I wanted to have you recall the fact that when we took the antiderivative, I simplified the fraction or split the fraction to end up using the power rule. So I ended up getting the general antiderivative g of x of the function g prime of x. So manipulating an expression in order to use one of our known antiderivative rules is what you're going to often have to do. Now, in example 3, we'll do a similar type of manipulation so that we can find an antiderivative. And in addition to that, with example 3, it says find the function f of x when f prime of x is equal to x times the cube root of x, and they're giving you particular information. So in this problem, unlike the previous one where we found the general antiderivative, we're going to be finding a specific antiderivative. So find the function f of x when f prime of x is equal to. So here we go. The first step I'm going to take, though, is I'm going to do a rewrite step on f prime of x. F prime of x, then, I'm going to rewrite as x times x to the 1/3. And you see that we have the same base. When you multiply powers with the same base, you can, of course, add their exponents. So we have f prime of x is equal to x to the 1 plus 1/3, which would give us f prime of x equal to x to the 4/3 power. So with that, then now I will begin to take my antiderivative. So I'm just going to write this antiderivative. Because now I have my expression for f prime written as a power, I'm going to take the antiderivative of x to the 4/3 by saying f of x, the function then, is equal to x to the 4/3 plus 1 over 4/3 plus 1. So we end up getting x to the 7/3 because 1 is, of course, equal to 3/3. So you get f of x is equal to x to the 7/3 over 7/3. You have a plus c, but if you recall with dividing by a fraction, you will, when you divide by 7/3, then you will multiply by the reciprocal. So the first term then becomes 3/7 x to the 7/3. So we now have our general antiderivative. So this is our general antiderivative. So now we want to get our specific antiderivative using the specific information f of 1 is equal to 2. So we have f of 1 being equal to 2. So right now f of 1 is then equal to 3/7 times 1 to the 7/3 plus c. And what this allows us to do is to solve for the arbitrary constant c for a specific antiderivative. So we get f of 1 is 2 is equal to, then 3/7 times 1, so we get 3/7 plus c. 2, if you recall, is 14/7, so you have 14/7 minus 3/7 would be equal to c. So you get c is equal to 11/7, which gives you the antiderivative, the specific antiderivative, f of x is equal to 3/7 x to the 7/3 plus 11/7. This is our specific antiderivative. Okay, so you may want to pause that and review, but I'm going to go on to the next example. So for example 4. Example 4, you can see we have a lot going on. We have up to the third derivative being sine x, and we have information about the function f of 0 is 1, the first derivative f prime of 0 is 1, and the second derivative f double prime of 0 is also equal to 1. We'll use the specific information to find f, the function. So the first thing I'm going to do is start with the third derivative. And remember, we're undoing derivatives, so we're going backwards from the third to the second to the first. So I'm going to start with f triple prime of x is equal to sine x. So when I take the antiderivative of sine x, I have the second derivative, f double prime of x, would then be equal to negative cosine x plus c. Remember, the derivative of cosine is negative sine, so the antiderivative of a positive sign would be negative cosine. Take some time to do a think cycle with that. So we know f double prime of 0 is equal to 1, and we'll plug a 1 in there. We have negative cosine 0 plus c. So we want to find out what c is at this stage. So what we're going to do is we're going to say, okay, f double prime of 0 is 1 is equal to negative cosine 0 is 1 plus c. We find out that c is equal to 2. So now we know that f double prime of x is equal to negative cosine x plus 2. Up here. So that's my first round. Now I'm going to come up for a second round. So now I want to get to f prime. So I've got f double prime, I've got f prime of x I'm after. So then I take the antiderivative of negative cosine x and I get negative sine x. Again, use your think cycle if that's a problem. Plus the antiderivative of 2 is 2x. Plus, I'm going to use another constant because you have an arbitrary constant that you'll have to put in. So I'm going to say d instead of c, just to make it a little different because it is a different constant. So then, now I know f prime of 0 is also equal to 1. So that's negative sine of 0 plus 2 times 0 plus d. So I get 1 is equal to 0 plus 0. The sine of 0 is 0. So I get d is equal to 1. So now I know that f prime of x is equal to negative sine x plus 2x plus 1. Now I'm going to take the antiderivative of the first derivative and I'm going to get f of x. So now f of x is then the antiderivative of negative sine is cosine x plus the antiderivative of 2x. I'm going to take this because you haven't been doing these for a long time. It's going to be 2x squared over 2. So now you see that that's just going to be x squared. Erase that real quick. So we get plus x squared plus the antiderivative of 1 is x plus, and I'm going to put an e on the end for the arbitrary constant. So now I know that f of 0 is also equal to 1. So I plug that in, plug 0 in on the right-hand side, and I get 0 squared, cosine 0 plus 0 squared plus 0 plus e. So e being the arbitrary constant, it looks like since f of 0 is equal to 1, we get 1 is equal to 1, cosine 0 is 1, plus e. So it looks like e turns out to be 0. So we have e is equal to 0, and we get our function then. Our function f of x then is equal to cosine x plus x squared plus x plus 0. So our specific antiderivative, this is our specific antiderivative, if you will, 3 times, but it's our specific answer for the problem given the specific information. And that's all for this video. Sign off, and we'll come back to example 5 in the next video.